Hello there, I'm just going to get started in a minute. Just give me a few moments to get started. Okay, so hi there. Thanks for attending our webinar on 1D line tracking. My name is Patrick Hope, and I'm a product marketing specialist here at Excitex, and I'm going to speak to you today about our 1D line tracking in ProAnalyst. So I'm going to take the next 25 minutes or so to review the 1D line tracking toolkit with you, show you some of the theory behind how it works, look at some of the features of the toolkit, and provide you with some examples of line tracking in real-world examples. I've disabled the audio for the duration of the webinar, but if you'd like, you can ask questions down in the chat below, and I will do my best to address these either in the webinar at the end or perhaps via email if it's a more difficult solution to that. So the general topics we're going to cover today on 1D line tracking is we're going to talk about the generality of what is line D tracking. Then we're going to look at the specifics of how to use the 1D line tracking toolkit. And then I'm going to go through a few examples that we have that showcase exactly how the toolkit works. So the 1D line tracking toolkit is available in ProAnalyst Professional and Professional 3D. And unlike 2D tracking, which we refer to as feature tracking, 1D line tracking does not track patterns. 1D line tracking isolates a line within the video and examines the transitions in pixel intensity or the derivatives of the intensity along that line. We can vary the thickness and position of the line and change the directionality of the line. In practical use, we often see 1D line tracking used to track like explosion fronts or do some stress testing or look at the expansion of objects or to get mechanical timing information. The process of performing a 1D line tracking consists of drawing a directional line from one point to another, choosing the appropriate transition for motion underneath that line, and following the motion in the subsequent frames. So there are several components that are important here that we just talked about. First of all is modifying the line. The most important thing to remember about 1D line tracking is that the lines have directionality. There's a point A, or it is a point 1 and a point 2. This appears as P1 and P2 in the software. This is important because later on we tell the software the transition type that we're looking for, either white to black or black to white, and it is this transition type which determines the location for the point on the line. The line view window, which we see in the upper part here, within the toolkit, allows us to adjust the line on a pixel by pixel basis. Lines can run diagonally through the video or they can be straight. It doesn't matter. And we're going to look at this line view later, and we're going to talk about exactly how we interpret it and what it does. The next important aspect is the search type. And this is how we decide exactly what sort of transition or what sort of factors are going to be involved in capturing the motion on the video. And in here, we can see there are four main search types. There's peak intensity, peak derivative, threshold intensity, and threshold derivative. And these are different values that determine and allow us to control exactly where on the line our point is going to be. And the transition type is the last important part. And that is just as simple as, are you looking to place a point where white turns to black, where black turns to white, or potentially both? We can have multiple targets on any single point, so it's quite conceivable that, I believe you can have up to 20 targets. So it's quite conceivable that you'd want multiple transitions or the both transition type. All right, let me get rid of my little thing. So, right here. Well, first, what I want to do now is I just want to take a minute to look at a static gradient that I created here within ProAnalyst. ProAnalyst is able to open still images just like videos, and that's exactly what I've done here. I created this gradient and I opened it up in ProAnalyst. And then I'm using the line view tool. It inspects the lines that's drawn along the center of the image. So this red line is our 1D line tracking. And again, it has a directionality in that it has a 0.1, which is right here, and it has a 0.2, which is down here. So as this line progresses in this directionality, it comes down and we get information about it in the line view tool. Right now I'm looking at intensity. This is a black and white image. All of the analysis done by ProAnalyst is done on a pixel intensity or derivative intensity value. So ProAnalyst doesn't care about any colors present in here. This could be a rainbow or it could be a solid color, but it's the transition and the intensity that it's important. So what we see here is we're seeing values of 0 and 255. This is similar to a histogram in the way it works, in that a value of 0 means that the image is absolutely black, and a value of 255 up here means it is a pure white. So as we progress across this line, we could see the spike up in the pixel intensity. And it goes like that. This is an important concept to remember, because the line view tool is one of the most valuable tools for understanding and just looking at a line and determining where the point is naturally going to be placed on that line. Okay. So this is what happens when we're looking for a peak search type. And in this case, I have both a peak intensity and a peak derivative value here. So you can see that the peak intensity is on the brightest portion of the gradient and the highest portion of the graph. And that's on the far right-hand side of both of them. The peak derivative exists on the steepest portion of the slope, or where the greatest change is in the line value. In this instance, the peak derivative exists on the left-hand side of the slope, but that's only because we're selecting a transition type of black to white. If we were looking for a peak derivative of a white to black, the peak derivative point would be right about here, and it would exist on this end of the graph here. So this is where the most changes is occurring, our peak derivative, and we can see it in the steepness of the slope. And again, if we're looking for just an absolute peak intensity, the brightest location, it is going to be the highest point on our line view slope for this. So the other type is threshold. When the threshold is selected, you can enter a threshold value into the open field. Once that value has been reached according to the directionality of the line, the point is placed. So in this instance, our threshold value is set to 100, as we can see over here. And that the end result is the software just basically draws a line in the line view tool at 100, so we can see at what point it is crossing, and it puts a a spot on the threshold here. And likewise, the threshold derivative, we can put a threshold derivative value, like say down here, that as soon as the derivative is met, i.e. the steepness of the slope is hit, then we get our derivative point in there as well. Okay, so that's the general theory behind what we're looking for and how we select a point. Now I'm going to go through and I'm going to look at the toolkit itself and exactly how it is that we go through and we use the software. So the 1D toolkit, again, is in ProAnalyst Professional and ProAnalyst 3D. And it allows for both manual and automatic tracking of points on a 1D line. You can add up to 64 lines, and you can compute multiple things like a circle fit. You can also use feature lines to join the 1D line points, just like a 2D feature set inside ProAnalyst. And it's also important to understand that within the 2D feature set, if you'd like, you can convert a 1D point into a 2D feature, so you can compare both 2D and 1D motion within a video. So the first thing you need to do when you're using this is you need to define a line. You need to set points on a line, and you build up a point set. You modify the line by clicking and dragging it along the desired path, and then you click on set the line to configure the line and set it off where you want it to be. And as I mentioned earlier, once you build these lines up, you will have multiple lines on your properties window. Each of these multiple lines has both a line display button as well as a generalized motion histogram image over here that can be toggled on and off as you see fit for using them. So the idea behind the line display is that it's giving you, like we said, an idea of the pixels visible underneath the line, and it updates in each individual frame. So every time you move, this line display is going to be different. So it's good to bring this up at a peak point in the video and do your configurations based on that point, so that you set your either intensity or derivative threshold values using the line display at a critical point in the motion of the video. You could track objects and you can adjust any of those values later on. And as well, like I mentioned, there's a manual feature in there. If you need to remove a couple of points, you can delete the points from the line tracking and then interpolate any missing motion data in there, just so that you get smoother data if there's some sort of interruption in the line. This often occurs with blasts, where the background is where the background showing the blast has objects in it that obstruct the blast at some point, or maybe there are trees or something in there. Just like every other tool in ProAnalyst, the 1D line tracking tool has a settings wrench, which opens up the settings for the window. Every time you see a wrench within ProAnalyst, you can click it to alter the settings for that toolkit, and 1D line tracking is no different. So you can set a label for the line, and you can also look at all the settings here. This is where we set our search type, our transition type, threshold values, number of targets, thickness, and the filter coefficient for the 1D line tracking tool. It's the exact same model as all of the other tracking types, including 2D feature tracking. In here, your search types and the transition types are the two most important and commonly used settings, but the thickness of the the thickness of the line is also important. So when we've been talking, typically by default, the thickness of a line is 1 pixel. So it's looking at an absolute intensity of those pixels along a single individual line. But if there's some sort of noise embedded in the video, you'll often find it's more accurate if you increase the thickness of the line. And so by increasing the thickness of the line, what you're doing is you're averaging the values across that line. And so you're getting a more representative idea behind the motion of the object itself. And this works perfectly well, except in the case of lines that would have an arc. If you increase the thickness of a blast where your thickness is a significant portion of the circumference of that blast, then you're going to start getting inaccurate numbers. But for the most part, it's a good idea to at least put some sort of thickness on the line so that you get more representative motion data from that. So again, here are all the search parameters that are available. And if you want to, you can click, and it's generally a good idea to set up multiple lines, and these settings can be applied to multiple lines within the 1D line tracking tool at the same time, just by clicking the Apply Settings to All Line button. So in terms of the intensity, as we spoke before, this is related to a peak search. You're looking for the highest value of intensity here. And in a black and white, what it's looking for is it's looking for that dark to light pixel transition intensities. So if you're going from a black to white, the intensity is looking for the whitest portion here. But if you switch this and you're going from white to black, well, the intensity has been inverted. So you're actually looking for the darkest pixel present on the video across the line here. And when you do both, what it does is it's going to take the greatest values from both types. So it's going to throw up 2 search points, the darkest and the lightest locations on the video across the line. And again, it's important to remember that when you first create the line and you have a 0.1 and a 0.2, the directionality of that line is what determines this transition. So if you're looking for an object, oftentimes just inverting the direction of the line inverts the transition type that you're looking to copy in this. And then again, for derivatives, this is obviously related to a derivative search or the slope of the transition between light and black or black and light. So if you're going from black to white on a derivative, you're looking for a positive derivative that exceeds whatever threshold value you set in place, or this would be a quick brightening of the image. And white to black is the exact opposite. It's looking for the negative derivative. So this is a quick darkening within the line itself. And both, again, adds points where the absolute derivative exceeds the threshold that you've put in place. So this can have multiple points on it, or it can be a single point where it's either gets the darkest or the lightest at that point within the video itself. So you can set a maximum thickness of 20 points. This video that we have here is of a blast mark on it, and as you can see, it's somewhat grainy. Well, the thickness allows you to sort of smooth the intensity of the pixels under the line and get a more representative idea of the motion behind that. Okay, now what I'm going to do is I'm just going to bring up a couple of examples, and I'll just look at the process of doing this here. So in this instance right here, this is a very typical application for a 1D line tracking here. This is a part of a wave machine, and it's going to study wave motions. So for this, we're looking at the meniscus of the water right here. But one of the things we didn't talk about, and which is a little bit beyond the scope of this specific webinar, but we'll deal with it in further webinars, is with image processing. Image processing is very important for the 1D line tracking tool. I mean, it's important for all the tools. But the general idea behind it is going to be that while we have this nice, beautiful picture, we're always looking to really sort of break the picture as much as possible and break down the components of what is the picture into the most into the simplest forms. So in this instance, I can adjust the brightness and gamma settings of the video to really make that line very distinct. And then while you're looking at the raw version here, it's a little abstracted in terms of how this is going to occur. But what we can do is we can tell the software to basically bring these blues and make them blacks, and bring the whites and make it pure white. And then in this case, we just completely inverted that through some filters. And so we've drawn these lines with the directionality, and we've set their values right here. So these, it's very simple and straightforward when you're just doing black and white transitions, because there's really no ambiguity for where the points are. These are all threshold intensities where black turns to white. So here we have our 1 point at the top and our 2 point at the bottom. And the threshold is 128, which is exactly in the middle between 0 and 256 or 255. And we're looking for a single target here. And then as we look at that, it provides a perfect little simulation of the wave. And down here, we've just graphed the motion of one of the lines. This is line 1, and the motion is graphed on that. Another common application for the 1D line tracking is to come up with timings for machines. And this is a video of a boat motor. I'll just play it through for a minute. And what the client wanted to do is they wanted to look at embedded frequencies that occur when this motor begins. So they want to compare the motion and rotation of the gears of the motor or the general operation of the motor itself with embedded motion of objects within it. So they've placed several targets upon the motor, and they're tracking these in 2D. But what they want to do is they want to compare the motion of these 2D objects with the inherent frequency of the machine itself. And the way to get the frequency of the machine is quite simple. We've just put several 1D line tracking here, and we've asked the software to find transition types. In this case, we're looking, so here's point 1. Here, we're looking for a white to black transition, and it's picking up the edge of these gears here. So that when we come through and we look at a graph, if I can bring up a graph of this, I can very quickly and easily see one of these is an unwrapped angle version of this, and the other one is just the progression of the motor itself. So this is giving us our frequency of the rotation of the motor here. And then we can compare that to the vibration that we're measuring in our 2D systems as well. 1D line tracking can also be used for expansion of objects and measuring general expansion. In this instance, we have an artificial heart valve, and the customer wants to monitor the opening of the heart valve and find frequencies of the opening and get a general idea of the area that is opened and the amount of flow that's going through it. So this is done with 3 1D line trackings here. You can see a red, blue, and green. And what it's done is we've added what's called a circle fit upon those 3 objects. And so it's developing a perfect circle based on the motion of those objects here by joining the 3 points. So you can do this with any number of points. It takes at least 3 to make a perfect circle, but the more you have, it starts adding a best fit circle in. So we could add several more in here, and it would give us a best fit circle for this object. And this is done in conjunction with our contour tracking toolkit here to get a more perhaps accurate size of area and perimeter of the artificial heart valve as it's open. But typically when people do this, they also add the 1D line tracking, because the 1D line tracking is a great way to get the frequencies of it, as these unfolding things typically happen in a sort of haphazard pattern. And if we look down here, we have the blue versus green line. So one is a radius of curvature and one is the area gathered through the contour. And you can see that they're, while not exactly, they're very representative of the motion of it itself. This same technique is often used on airbags to determine the average airbag expansion rate. And yep, that's how it looks when it closes. The 1D line tracking tool can also be used for deformation analysis. In this instance, we've got a helmet. Let me play this from the beginning. That gets struck, and we want to measure the average constriction of the helmet during the strike as it occurred. And so to do that, we've got multiple 1D line tracking tools going out here, and we've done a best fit circle. As I mentioned, this is a best fit circle over 6 points here to measure the deformation of the helmet. Just like that. And again, we can come down here and we can graph lots of information on those. So in this instance, we're looking at the radial speed of the 1D line tracking circle. So we're looking at its ability to react to the strike and to bounce back into its previous position. So this is a video of a watch spring as it loads and unloads. And what we've done here is we've tracked a point along the watch right here, a spring. We've tracked this with 2D, but we've come through here in 1D, and we want to see how the rotation and motion of this object along the watch spring relates to the springs itself. So to do that, we've placed a 1D line in here, and we've just told it, let me open this up, we've told the 1D line to allow for multiple targets. So we've given the 1D line some thickness. We've given it thickness 4, and we're looking for derivative values. So we're looking for the changes within that. And what we've done is this will pick up all the points of the spring along the watch and set those as points. So what we can do is we can then measure all of those values in our feature lines. So I've got several feature lines built on this, which are just looking at multiple targets within the line. So the first line is the orange one over here, and that's from line 1, target 1 to line 1, target 2. The second one is line 1, target 2 to target 3, and et cetera, et cetera, et cetera. And by doing that, we can come in here and we can graph all of these lines, and we can look at the comparison between the motion of, let me turn them all on, the motion of the spinning object with the compression between these lines on the spring. And almost at the last example I have, this is a video that we captured of, it's a very, very small object, but the end user wanted to look at the shaking. There, you just saw one there, and the vibration between these two objects. These two objects, as the machine is operating, are rubbing back and forth together, and they want to understand what frequency that these are rubbing on. And so there was some jitter in this video, so the video has been stabilized, and you can see some strobing effects because the lights are obviously the frequency of the lights is a little bit is quite visible within the software because we're shooting this at 2,000 frames per second. So what's been done in this case is to compensate for the strobe effect and to get a good idea of where this point is. We've set up a really thick line, and we're just monitoring the motion of that single point. And as we see it shift, that represents the frequency of the movement of these two objects together. And then the last example I'm going to do here, I'm actually going to do it sort of live in person so we can see how this process works. This is a tattoo machine. And the request was made to find the how often the lever here is contacting the this portion of the tattoo machine. They wanted to find the frequency of touching versus not touching, because that allows that determines how the needles are set in the tattoo machine. So the first thing we're going to do with something like this is typically we would calibrate this shot and we would find some known distance to put in it. But where they're just looking at frequency, they don't actually care about distances. So the only calibration that needs to take place is a temporal calibration, or we need to basically tell the software what the frame rate of the video is. Now in this case, we can see up here in the record rate that is set to 5,000 frames per second. This video already knows what it is. That's because the camera that captured this would have embedded this metadata into the file that it's in. But if we did not know that, I could come through here and I could alter the record rate manually and tell it more information. So with that done, what we want to do is we want to take this beautiful video and really distill it down into the motion that we're looking for. And what I'm going to intend to do is I'm going to put a 1D line tracking right from this point to come down to track and follow this object right here. And then what we'll do is we'll set the value of that as 0 or touching, and as it comes down here, it'll be greater than 0 or not touching. So to do that, I'm going to come here. I'm going to calibrate this shot and just set an origin point for it to be touching. And right now, the Y positive directional value is going to be right there. I'm going to shift my X-axis just to have the Y direction pointing at a right angle to the motion. And let me apply that and close it. So once we get done here, we're going to look for Y positive values. And then I'm going to break this video as much as possible, like I said, and distill the motion. This one's pretty easy to do because I could just increase the contrast. And increasing the contrast makes it super easy because I don't have to care as much about the intensity values if I can get this proper. You know, if I can get this to work out right. So I just want it so that I've got a slither of black right there and going to the white. So now when I turn on my line tracking, I have to enable it. And enabling the line tracking, it takes a bit of memory from the machine and it allows you to start storing objects and information within the line tracking itself. None of these features are enabled by default because we don't want to be eating up all your memory if it's not necessary. So when I enable it, it automatically gives me by default a single line. I can modify this line here. and draw point 1 to point 2. This doesn't have to be very long, but the trick is I want it to start within the black and move out. So now I think this looks okay, so I'm going to set my line right like that. And I can just scroll in just to make sure. Yeah, I think it's outside of the black. So now I'm going to open up the line settings in here, and this is showing me what's going on within the line. So it's showing me all these peaks up here. Let me just look at the intensity. It's showing me all these peaks. So this peak here represents the bar coming across here. The second spike is this little white spot in here, and the third spike is the one down here. So we want our dot to exist right on the front end of this. So I'm looking for a peak intensity where black turns to white. I'll give this line a little more thickness, just, well, maybe not that much. Just to smooth out the results there a little bit. And then let's check to see that that works. That brought me down in here. Peak intensity from black to white with a thickness. Is my thickness too high? Let's do a threshold of intensity. So this should be 128. Then I'm going to track that through. Here we go. So as you can see, it's putting the point on there, it's following it down, and it's following it back up. So now as I can scroll out and just let that work. There's about 1,000 frames in here, I guess. Oh no, there's a couple hundred, I guess. So I'll just give that a few minutes to work, and then I'll graph the data and look at it. There are a few spots where it's where I can see it disappearing here or moving around, and we can smooth that out, or probably the better thing to do would be go back and refine, maybe make it a bit thicker, or maybe change up the absolute location of the line, or clean it up somewhere. But for a couple minutes, I'm hoping this is going to be pretty good. So that's it. It's been tracked. So now what I'm going to do is I'm going to come in here to my graph, and I want to add a graph. I want to graph that 1D line. And because I set my point here, I think I want to look for my target, my line 1, target 1 Y coordinate. So if I do that, here we go. And these are the values we're looking at right here. And so that was gathered in about 2 minutes using 1D line tracking. And like I said, it appears that there are a few spots, like right here, there's a spike that goes right here. So something probably happened at that point. And we can go inspect those and clean those up later. But that's a general overview of how this works, as well as an example of what's going on here. So in this webinar, we covered information about what line tracking really does and the theories behind it. We talked about the search and transition types and the peak versus derivative search types, and we spoke about the line display and line summary boxes in here, and I gave you some examples of what was going on. So that's the end of the webinar. If you have any questions, I'm more than happy to answer them now, or if you'd like to email me later on with any further questions, you are very welcome to do so. And thank you guys very much.